Hello students, welcome to my online physics class. So let's start. Today topic is related with the prism. Here you are seeing one prism, a regular prism consisting of two triangular faces and three rectangular faces. This one is rectangle, this one is second rectangle, this one is third rectangle. And here all the triangular faces as well as the rectangular faces are equal separately. So now start. So first of all, we draw one face of the prism. Okay, just I am drawing one a refracting face of the prism. Okay, now at this point we draw a normal over here. Let us suppose this is the incoming ray or incident ray. You can say incident ray, and inside it generally moves parallel to the nearly parallel. It's not perfectly parallel, okay, it's nearly parallel, okay, and thereafter it makes incident on the second face. The first face is here AB, the second face is AC, and here at the point, let us suppose this one is P, this one is Q, this one is R, and at this point it emerges out of the prism. Okay, so this is our emergent ray. Okay, now again at this R point we draw a normal. Okay, and at this point another normal is drawn. It cuts the normal, both the normal cuts at the point O. Okay, now this is the incident ray direction, that is the original direction of the ray, and this is the emergent ray direction, final direction of the ray after introduction of the prism. Now these two lines mix some angle with each other, and here this angle is known as angle of deviation. So this is the angle of deviation delta, this is the incident ray direction. So incident ray direction and emergent ray direction both makes an angle delta with each other, and this one is known as angle of deviation. We have to find out an expression for it. Here this angle, okay, it is generally 60 degree and it is known as angle of prism. This one is known as angle of prism. Let us suppose that here the angle of incidence is I1. Okay, now and this one is the ray direction, the angle is here R1. Okay, by convenience, okay, or you can say that for convenience we use R2 symbol over here, because at the point R you may think that it should be angle of incidence, but I chose it due to one reason I will tell. And let us suppose this angle is I2. So using the Snell's law at this point, if I use the Snell's law, what does Snell's law say? Snell's law says, let us suppose the refractive index of air is 1. So Snell's law says n1 sine theta 1 is equal to n2 sine theta 2. So if I use this formula, I will get the expression like this: sine I1 divided by sine R1 is equal to sine I2 divided by sine R2. Okay, so this is the expression, and only to get the familiar expression like I1 I2 should be in the numerator, I chose this one as I2, although it is the angle of emergence, or you can say that angle of refraction at the point R. But if you use the Snell's law at the point Q and at the point R, you will find that this expression is right. Okay, so right now I'm leaving it. Now see here, what is this angle actually? What is this angle? If this one is I1, the whole angle, this whole angle will also be I1 because they are vertically opposite to each other. So if this one is I1, this one will be equal to I1 minus R1. Similarly, this one angle will be equal to, if this is I2, the whole angle will be I2, but out of I2, this one angle is R2. So only this angle is, just put a cross question mark over here, this angle will be equal to I2 minus R2. See, now addition of these two interior angle will give the sum, will give the external angle or exterior angle of the triangle. See, just drawing a rough picture over here. If this one is theta 1 and this one is theta 2, and let us suppose this one is our delta, so delta must be equal to theta 1 plus theta 2. We know it from the laws of geometry. So we can write here this one is equal to delta. So on simplification we will get I1 plus I2 minus R1 plus R2 is equal to delta. Okay, let us suppose this one is our first expression 1. Now again, in the quadrilateral AQOR, see, AQOR, okay, this angle A, this is angle A, this is angle, see here, this whole angle, it is actually normal. This whole angle will be equal to 90 degree plus O, angle O plus, and this angle will also be equal to 90 degree or right angle, and altogether the sum total of all the four interior angles of any quadrilateral is actually 4 into right angle, that is 360 degree. So on simplification, 90 degree 90 degree, it will become 180 degree, and if I may move it on the other side, 360 degree minus 180 degree will be equal to 180 degree, and this will be equal to angle A plus angle O. So this is one is our second expression. So angle A plus angle O is equal to 180 degree. Okay, there is some space problem. Okay, now angle A plus angle O is equal to 180 degree. Similarly, here see, in this triangle QRO, see, this one is Q, this one is R, this one is O. Okay, this one angle is R1, this one is R2, and this one is O. So angle R1 plus angle R2 plus angle O is equal to sum total of all the interior angle of a triangle is 180 degree. Okay, so see here, this is our third expression. This one right hand side is 180 degree, this one right hand side is also 180 degree. So we can equate the equation 2 and equation 3. So from equation 2 and 3 we get angle A plus angle O is equal to angle R1 plus angle R2 plus angle O. See, something is cancelling out and that one is angle O. So in short we are getting angle A is equal to angle R1 plus angle R2. So this is the expression, and this is an important expression. See, let us suppose this one is our equation 4. So the expression 1, that is delta, this one, see, this one I1 plus I2 minus R1 plus R2. So in place of R1 plus R2 we can write A. So simply we will write delta is equal to I1 plus I2 minus R1 plus R2, I1 plus I2 minus A. So this is the expression, final expression for the angle of deviation. This is the final expression for the angle of deviation. Now if I plot I, angle of incidence, okay, along the x-axis, and delta along the y-axis, I get a curve like this. Okay, so if for a certain delta, let us suppose at this point, if I draw a line, it cuts at 2 points, at this point and at this point. Just draw a perpendicular on the x-axis. So let us suppose this one is I1, this one is I2. So for a certain delta, there are two angle of incidence. There are two angle of incidence, I1 and I2. And here I also want to say that in this picture, if any mirror is placed at an angle of 90 degree with the emergent ray, then by the rule of principle of uh, reversibility of light, it will follow the same path, and here I2 will be equal to angle of incidence and this I1 will be equal to angle of emergence. So ultimately I1 and I2 will interchange each other, but the delta will not change. So if I1 and I2 are replaced by each other, in place of I1 if I put I2 and in place of I2 if I put I1, a delta value is not going to change. And that's why here we are finding that if one is angle of incidence, the other one is angle of emergence. And for a certain angle of incidence, for a certain angle of minimum deviation, we are getting two angle of incidence, or you can say angle of emergence. So if we decrease the value of delta, if I go on increasing the value of angle of incidence, a point comes when these I1 and I2 will come closer to each other and will coincide to each other, and that is the angle of incidence, that is IM, okay, for the minimum deviation, because at this point delta is minimum. So at delta is equal to delta M, I1 is equal to I2, that is angle of incidence is equal to angle of emergence. And if it is possible I1 is equal to I2, we can also say R1 must be equal to R2. How? Let's prove it. R1 is equal to R2, we have to prove. So we know very well that n is equal to sine I1 divided by sine R1, sine I2 divided by sine R2. As we know that at delta is equal to delta M, I1 is equal to I2. So we can write here, we can actually cancel out this I1, sine I1 and sine I2. So these are cancelling out. So ultimately we will get sine of R1 is equal to sine of R2, and at last we will get R1 is equal to R2. See, so we have proved it. At delta is equal to delta M, I1 must be equal to I2 and R1 must be equal to R2. Now next things. Delta at minimum deviation position. At minimum deviation position, that is delta is equal to delta M, I1 is equal to I2. Let us suppose that this is I, say, because both are equal, and similarly R1 is equal to R2 is equal to R, say. Okay, so in that case delta must be equal to, see the formula, I1 plus I2 minus A, see this one formula. So putting this value, I plus I minus A, I get 2I minus A. So delta is equal to 2I minus A. So on simplification, 2I must be equal to delta plus A. Oh, one thing, it should be delta M. Okay, it should be delta M, delta M, delta M plus A. So I must be equal to delta M plus A divided by 2. Similarly, we know that A is equal to R1 plus R2, but R1 is here R and R2 is also R. So just putting this value, we are getting r is equal to I2. So see here, we are getting I is equal to this one and r is equal to this one. Okay, just there is a problem of space. See. Okay, r is equal to I2. Now we know that n is equal to sine I divided by sine r. We know very well. Actually, the relation was like this: sine I1 divided by sine R1 is equal to sine I2 divided by sine R2. But at the position of minimum deviation, I1 must be equal to I2 and R1 must be equal to R2, and we can write uh, only simply I or and R. So simply I wrote sine I divided by sine R. Put the value of I. Here the value of I is this one, sine of delta plus m divided by 2 sine of, put the value of r, a by 2. So this one is the expression, n is equal to sine of, see, sine of delta m plus a divided by sine of a by 2. So on putting this value, we are getting this expression. See, in this expression there is no angle of incidence, there is no angle of refraction. Okay, only the value of delta m and the value of a, that is angle of prism, is present. Okay, and this one is the refractive index of any prism. So for a certain prism, okay, angle a is fixed, its refractive index is fixed. So for a certain prism, the value of delta m, that is angle of minimum deviation position, will also be fixed. It is not depending on the angle of incidence or angle of emergence. Whatever be the angle of incidence, the value of delta m is not going to change, because in the expression there is nothing, there is no I, there is no r. Thank you for watching the video, and if you like, you can share it with your friends so that other students will also get benefited. Thank you.